Okay, so get this. Are you ready for this? We're going to be talking about cutting the trip to Mars in half, down to like 4 months.
Wow.
I know it sounds crazy. It sounds like straight out of Star Trek.
Right.
It's all thanks to this company, Pulsar Fusion, and their concept called Sunbird, which is a fusion-powered rocket. Today, we're doing a deep dive into whether or not this is actually possible.
Okay.
And we've got a great article to break it down. It's called Sunbird, A New Dawn for Fusion-Powered Interplanetary Travel.
That's so interesting. And what I think is so fascinating is how this company, Pulsar Fusion, is a UK-based startup.
Right.
Taking on these giants of the space industry.
Yeah.
And it really is a David and Goliath story.
Totally. You don't usually picture like cutting edge space tech coming out of like, you know, a small startup.
Right.
But all right, so before we go any further, fusion, everyone's heard the word, but what makes it so different for space travel?
Yeah, so fusion is all about joining tiny atoms together.
Okay.
Think hydrogen. And when that happens, boom, huge amounts of energy get released.
Right.
And unlike fission, which splits atoms and leaves behind radioactive stuff, fusion is a lot cleaner and way more energy dense.
So basically fusion is like the super efficient fuel that can like really take us further and faster.
Exactly. Think about it. You'd need way less fuel for missions.
Right.
And with all that extra power, we could actually finally reach those far off destinations, you know, the ones we've only dreamed of.
Like, okay, wait, haven't there been ideas for nuclear rockets before?
Yeah.
Like, didn't they try something crazy like using actual explosions for propulsion?
Yeah, that was Project Orion.
Oh, wow.
Pretty wild idea back in the day.
Really?
They figured, why not ride the shock waves from like controlled nuclear blasts?
I mean, what could possibly go wrong? But seriously, like, why didn't those earlier projects work out?
Well, a bunch of reasons, like huge technical challenges.
Yeah.
Also the fact that they like banned nuclear testing. And of course the costs through the roof. Like even NERVA, you know, that was a slightly less dramatic nuclear thermal rocket.
Okay.
They had issues with materials and efficiency.
So Sunbird, with its fusion approach, kind of like sidesteps a lot of those problems.
Precisely. Plus they're using this very unique dual direct fusion drive architecture.
Okay.
Which I'm sure you're curious about.
Dual direct fusion drive? Yeah, that definitely needs some unpacking.
Essentially, it's two fusion reactors working together to create thrust. And the direct part is key. That means the energy from the fusion reaction goes straight into pushing the rocket forward.
Okay.
You know, there's no wasted energy along the way.
So it's like a supercharged engine with no kit stops.
Yeah.
I'm still wrapping my head around how this actually works. Can we break it down a little bit?
Yeah, of course. So picture this. A fusion chamber. This is like the heart of the engine.
Okay.
Where the magic happens. And inside you've got plasma, which is basically superheated gas at millions of degrees.
Millions of degrees? That's hotter than, well, anything I can think of. Like, how do they even contain something that hot?
They use these incredibly powerful magnetic fields.
Oh, wow.
To keep the plasma from touching the chamber walls. So think of it like an invisible force field.
Yeah.
Holding this insanely hot stuff together.
Okay, now that's some serious science fiction tech becoming reality.
Right.
So how does that hot plasma actually make the rocket move?
This is where the direct part comes in. Sunbird doesn't burn fuel like a regular rocket.
Okay.
Instead, it converts the energy from that plasma directly into thrust.
Right.
That's what makes it so incredibly efficient.
So it's less like burning fuel and more like channeling pure energy.
You got it. And get this. The engine can be restarted and adjusted multiple times.
Oh.
It's not a one-shot deal like a lot of conventional rockets.
Hold on, so reusable. That changes everything.
Right.
Imagine a rocket that can make multiple trips, like a space shuttle for the solar system.
Yeah.
Talk about revolutionizing how we approach space travel.
Exactly. It wouldn't just be about reaching Mars faster. It's about opening up a whole new era of exploration and development throughout the entire solar system.
Yeah. I'm starting to see why this Sunbird is such a big deal.
Yeah.
We're talking about like shifting from single-use rockets to something more like a fleet of reusable spacecraft.
Yeah.
Like interplanetary ferries.
Exactly. And with those kinds of capabilities, the possibilities for what we can achieve in space are almost limitless.
All right, I'm officially on board with this Sunbird concept.
Yeah.
But before we get ahead of ourselves, let's take a closer look at how it compares to the rockets we use today.
Good points.
Let's dive into some of those comparisons.
Okay, let's see how Sunbird stacks up against the competition.
Yeah.
All right.
All right, so we've established that Sunbird has like some serious advantages over these traditional rockets, but how does it actually, measure up in terms of the hard numbers?
Well, one of the most important metrics for rocket performance is specific impulse, which essentially tells you how efficiently a rocket uses its fuel.
Okay.
And in this area, Sunbird blows chemical rockets out of the water.
Okay, I'm intrigued. Lay it on me. How much more efficient are we talking here?
Think about it this way. Current chemical rockets, they have specific impulses in the hundreds of seconds. But Sunbird could potentially reach tens of thousands of seconds.
Wow.
That means for the same amount of fuel, Sunbird can go way, way further.
Wow, that's not just a little bit better. That's like a whole other league. I mean, what does that kind of efficiency translate to in practical terms?
Well, it means that we could drastically reduce the amount of fuel that we need for missions.
Right.
Imagine launching a spacecraft to Mars with a payload that's actually substantial.
Right.
Scientific equipment, supplies, maybe even habitats.
It's always felt like we're just limited by how much weight we can launch into space.
Exactly. With Sunbird, we wouldn't be as constrained by fuel mass, which would open up so many possibilities for bigger and more ambitious missions.
So more fuel efficient, more powerful, and reusable.
Right.
Sunbird sounding less like a concept and more like the future of space travel.
Yeah.
But let's be real here for a second. We've talked about the challenges, right? The mind-blowing temperatures, the magnetic fields. What else are they up against to make this a reality?
Yeah. One of the biggest hurdles is controlling that superheated plasma.
Right.
Making sure that it behaves exactly how they need it to.
Because we're talking about millions of degrees here, right? What kind of materials can even handle that kind of heat?
That's a huge area of research, developing materials that can withstand those extreme conditions inside the fusion chamber.
Yeah.
It's not just about surviving the heat, though, but also the intense pressure and the radiation.
I can't even imagine what goes into creating something that can withstand that kind of environment.
It requires cutting-edge material science, pushing the limits of what we know about materials and how they behave under extreme stress.
Okay, so assuming they crack the material science cloud,
right?
Then what?
Well, they've got to figure out how to convert that fusion energy into directed thrust. It's one thing to create the reaction.
Right.
It's another to actually channel it efficiently to propel a spacecraft.
It sounds like a very delicate balancing act.
It is.
Controlling the plasma, channeling the energy, and making sure the whole thing doesn't, melt down.
Exactly. And on top of all that, they need a control system sophisticated enough to manage all these complex processes.
Right.
A system that can actually adapt to the, ever-changing conditions of space.
So you're talking about a system that's basically like the brain of the spacecraft.
Precisely.
Making sure that everything runs smoothly.
It has to monitor and adjust everything.
Wow.
The magnetic fields, the fuel injection, the thrust output.
Yeah.
Constantly making, micro adjustments to keep the engine running at peak performance.
So a lot of technical hurdles to overcome.
Yeah.
But Pulsar Fusion seems to be taking a pretty systematic approach, right?
Absolutely. They've got a detailed roadmap for testing and development.
Okay.
The first step is rigorous lab and ground-based testing.
Right.
Which they're planning to start next year.
So they're basically going to put this thing through the ringer here on Earth before they even think about launching it.
Exactly. They need to prove that the core concepts work, that they can create and maintain stable plasma.
Yeah.
That their magnetic confinement system can handle these extreme conditions.
So these early tests are all about proving that the science behind Sunbird actually works.
That's right. It's about validating the physics, gathering data, and making refinements before they move on to the next stage.
Okay.
Which is where things get really interesting.
Wait, it gets even more exciting than a fusion-powered rocket. I'm hooked. Tell me more.
Well, if all goes well with the ground testing,
right,
the next step is an in-orbit demonstration.
Okay.
They're aiming for as early as 2027.
Wait, so in just a few years, we could potentially see a Sunbird prototype actually flying in space.
That's the goal. It's incredibly ambitious.
Yeah.
But it's crucial for proving that Sunbird can operate in a real space environment.
That's wild. I mean, think about it. This small startup could be the first to demonstrate fusion propulsion in space.
Right.
That's a game changer.
It would definitely be a historic moment, and the data they gather from those in-space tests would be invaluable for further development and refinement.
Yeah, I bet the entire space community will be watching those tests very closely. But okay, let's say they nail the tests.
Right.
Sunbird works exactly as planned.
Yeah.
What happens then? What does this technology mean for the future of space exploration?
Well, for starters, it could completely change the way we think about missions to the outer solar system.
Because we'd finally have the speed and efficiency to make those missions a reality, right?
Right.
We're not just talking about Mars anymore. We're talking about the moons of Jupiter, Saturn, maybe even beyond.
Exactly. Missions that would take in decades with conventional propulsion systems could be accomplished in years.
Wow.
Maybe even months with Sunbird. And that opens up a whole new realm of possibilities for scientific discovery.
It's like we've been stuck in low Earth orbit.
Yeah.
And Sunbird is the key to unlocking the rest of the solar system.
And it's not just about the speed.
Right.
Remember, Sunbird can carry heavier payloads. So we could send larger, more sophisticated probes and rovers to these distant worlds equipped with instruments and technology that, we can only dream of today.
That's a great point. It's not just about getting there faster.
Right.
It's about what we can do once we arrive.
Right.
And of course, we can't forget about the implications for human spaceflight.
Right. The dream of sending humans to Mars and beyond.
I mean, a 4-month trip to Mars, that changes everything.
Right.
The shorter travel time would drastically reduce the risks associated with deep space missions, like radiation exposure and the psychological effects of prolonged confinement.
Exactly. It makes those missions much more feasible, both from a logistical and a human perspective.
Okay, so we've got faster travel times,
right,
heavier payloads, the potential for groundbreaking scientific discoveries, and maybe even paving the way for human settlements beyond Earth.
It's pretty remarkable to think about.
Yeah.
But it is important to remember that we're still in the very early stages of development here.
Right.
There's a lot of work to be done before Sunbird becomes a reality.
Right. It's all very exciting, but we need to stay grounded, too. I mean, we're talking about a technology that could potentially change the course of human history.
Absolutely. And with that kind of power comes a responsibility to consider the broader implications, both positive and potentially negative.
Well, I think that's a good place to pause and reflect on what we've discussed so far.
Yeah.
We've covered a lot of ground, from the technical details of Sunbird's design to, the potential impact on space exploration. But we've also acknowledged that there are, challenges and risks to consider.
It's a complex topic with far-reaching implications.
And one that deserves careful consideration and open discussion.
Absolutely.
So when we come back, let's delve into those broader implications.
Okay.
Explore the potential benefits and risks of fusion-powered space travel, and discuss what all of this means for the future of humanity's relationship with the cosmos. Okay, so we've been talking about Sunbird and its potential to revolutionize space travel. But one thing that really stuck with me is this whole idea of reusability.
Yeah, it's a pretty big deal, isn't it?
Totally. We're so used to the idea of rockets being single use, launch once and then become space debris. But with Sunbird, it's more like having a space truck that can make multiple deliveries.
Exactly. Imagine Sunbird shuttling payloads and astronauts to, say, a lunar outpost, or even acting as kind of like a tugboat,
Yeah.
moving large structures for a space station in Mars orbit.
Yeah, it's the difference between taking a one-way flight and having a reliable transportation system back and forth.
Yeah, that's a great analogy.
Yeah.
And it has huge implications for, the cost of space exploration. If you don't have to build a new rocket for every mission, the cost per launch goes down dramatically.
That makes sense. It opens up so many more possibilities when you're not constantly starting from scratch.
Right. And it could even spark a whole new era of space-based industry and commerce, with companies routinely transporting materials and goods between Earth and other planets.
It's amazing to think about what that could mean for the future of humanity in space. Okay, before we get too lost in the possibilities, let's come back to the here and now for a second. We've touched on how much more efficient Sunbird is compared to conventional rockets. Can you elaborate on that a bit more?
Sure. So when we talk about rocket efficiency, we often refer to specific impulse, which is basically a measure of how much thrust you get for a given amount of fuel. And in this area, Sunbird has the potential to be orders of magnitude more efficient than chemical rockets.
Okay, break that down for me. What does that actually mean in terms of, say, a mission to Mars?
But with chemical rockets, you need an enormous amount of fuel just to escape Earth's gravity. And then you need even more fuel to accelerate to Mars and slow down once you get there.
It's like filling up your car's gas tank multiple times just to, drive across town.
Exactly. But with Sunbird, you could potentially make the entire trip to Mars using just a fraction of the fuel. And that translates to a lot of advantages.
Like being able to carry heavier payloads or having more flexibility in mission design.
Right. And it also means shorter travel times because you're not as limited by, the amount of fuel you can carry.
So it's not just about efficiency. It's about opening up possibilities that simply aren't feasible with today's technology.
Precisely. It's about expanding our reach into the solar system and beyond.
Okay, I'm convinced Sunbird has the potential to be a total game changer, but I'd be remiss if I didn't bring up the risks and challenges, We're talking about nuclear fusion here, and anytime you introduce that into the equation, there are concerns.
Of course, and it's important to acknowledge those concerns. While fusion is inherently safer than fission, there are still risks associated with, any nuclear technology.
Like the potential for accidents during launch or operation.
Right. And we also need to consider the environmental impact.
Mm-hmm.
Even though fusion produces, far less radioactive waste than fission, these are things that Pulsar Fusion will need to address very carefully as they, develop and test Sunbird.
It sounds like they have a lot of responsibility on their shoulders.
They do. And they'll be under intense scrutiny from, the scientific community, regulatory agencies, and the public. Mm. But I think that's a good thing. It means that the development of this technology will be approached with caution and a focus on safety.
And hopefully that careful approach will lead to innovations and safeguards that benefit not just space exploration, but also other areas where nuclear technology is used.
I agree. The challenges are significant, but the potential rewards are enormous.
So as we wrap up this deep dive into Sunbird, I think it's safe to say that we're all eagerly watching to see what Pulsar Fusion accomplishes in the coming years.
It's a journey full of unknowns, but one that could ultimately lead to a profound shift in humanity's relationship with the cosmos.
Imagine a future where we're not just visitors to space, but active participants, traveling between planets with ease and establishing a permanent presence beyond Earth.
It's a future worth striving for, and who knows, maybe Sunbird will be the key that unlocks that future. Thanks for joining us on this deep dive, and until next time, keep looking up.